Good morning. Today we're going over our second lecture on dimensional analysis, and today we're going to look at some more complicated conversion factors. Specifically, we're looking at things that come built in with a conversion factor, and the word you're looking for here is per. If you ever hear something per something, then you're looking at a built-in conversion factor. So as an example, density can be given as 0.785 grams per milliliter, or speed could be given as 60 miles per hour, something like that. So let me just show you a little bit of what that might look like. You have a density of 0.785 grams per milliliter. And what that really means is that for this substance, this is alcohol, then every 1 milliliter has a mass of 0.785 grams. Now you could recognize that as an equivalency, and you can make two conversion factors out of it. You can have 0.785 grams per milliliter. You see when I said per, I drew that line underneath. And that of course also means that every 1 milliliter contains 0.785 grams. So these are two conversion factors. And as soon as you see that per, then you know that means divided by. 0.785 grams divided by milliliters. That's what we have in this expression on the left. And then of course you can flip it at will to get the expression on the right. And so now you have two conversion factors, and it's built in as a conversion factor because they said it was something per something. So again, if we have another example, we have a velocity of 60 miles per hour, or 60 mph. And you say, oh, I see that per, it means divided by. So what I have is 60 miles divided by every 1 hour. This is a conversion factor that arises from the equivalency of having, if I have traveled 60 miles, then I have traveled for 1 hour, or if I've traveled for 1 hour, I've traveled for 60 miles. And of course, we also have the option of 1 hour over 60 miles being an appropriate conversion factor that we could use based on this kind of notation. So one reason that I teach this to you guys is that drug dosages often have this kind of built-in conversion structure. Your dosing protocol is almost always given as a mass of your drug, whatever medication that you are administering, divided by the mass of the person that you are administering it to. And that way they can give a drug dosage that works for everybody, regardless of how big they are, because then you can factor in the mass of the person when you're doing your dimensional analysis. So for example, we might have a dosing protocol of 10 micrograms of drug per kilogram of patient, and they're just going to express that as 10 micrograms per kilogram. And they don't say, even though I will always encourage you guys in this class to say, oh, that is referring to whatever the medicine is, 10 micrograms of medicine per kilogram of person, because otherwise you're going to get confused and try to cancel out grams or something here. But it is standard protocol to not have to specify that. It's just 10 micrograms per kilogram, and you always know that the patient here is in the bottom. And of course, you can flip that, right? So that would be the same as saying that every 1 kilogram of person receives 10 micrograms of drug. Both of those are interconvertible conversion factors. And so we can do dimensional analysis with conversion factors like this. Let's do an example here from the lecture notes. And we have in the lecture notes this description. We've got a solution of cough syrup that contains 120 milligrams of acetaminophen in every 5 milliliters of solution. And the question is, how many 5 milliliter doses can be taken per day if the acetaminophen intake should not exceed 1,000 milligrams? Now, to make your life a little bit easier doing these problems, I'm going to make a couple recommendations. And the first is to be very systematic. The first thing you're going to do when you're faced with a word problem like this is to pull out all of the data that they've included. So for instance, you can say, all right, there's a divider there, 120 milligrams per 5 milliliters of solution. So I can say, all right, I know that 120 milligrams of acetaminophen can be found in 5 milliliters of solution. That's an equivalency. All right. And I see here how many 5 milliliters doses. That's telling me that 1 dose is equal to 5 milliliters of solution. And then the last piece we're looking for, we want how many doses per day if the intake should not exceed 1,000 milligrams. So we see that in 1 day, we need to have no more than 1,000 milligrams of acetaminophen. So these are all the conversion factors. This is all of the numbers and data that I can pull out of this word problem as given. I know a lot of students have issues with word problems. This is my first recommendation, is to stop making it a word problem and pull out all the numbers, because the numbers is what we're dealing with, what we're working with, just to help make it clear. Step 2 is to identify what are the units that they're looking for. And if I look here, I can see they want to know how many doses per day. So I'm looking at doses per day. So the units that they are looking for is doses per day. So we're going to set this up with dimensional analysis so that we get units of doses on top and days on the bottom. Now, there's 2 ways to go about this. Actually, there's more than 2 ways, but there are 2 general methods that are often used. And one of those is to start at the beginning, and one of these is to start at the end. What I mean by start at the beginning, I'll put this in quotes here, versus to start at the end. The strategy to start at the beginning is to say, okay, I'm just going to take one of these numbers and work from that, like 1,000 milligrams. So I might put my 1,000 milligrams here on top, and that comes with day. To include that. And now I want to cancel out, I don't want to cancel out days because I have that on the bottom. That's great, but I do want to cancel out milligrams of acetaminophen. So I'm going to find milligrams of acetaminophen in all of these numbers that I pulled out, and I see it up here in the top. I'm going to put that on the bottom so that they will cancel. And of course that comes with 5 milliliters of solution on top. Now my milligrams of acetaminophen cancel. And now I have the number of milliliters to be taken in a day. Well, we want doses and not milliliters, so we need to cancel out milliliters. And here's another place where I have milliliters. So if I put that here at the bottom, and I put dose up on the top, then my milliliters cancel, and I end up with dose on top and day on the bottom. And that's exactly what I'm looking for, so I know that I'm done. And I can plug this into my handy dandy calculator and find the answer. Easy peasy. So we have 1,000 times 5 divided by 120, and then divide that by 5 to get 8.33 doses per day. Now that's starting at the beginning, starting with something like, oh, I see 1,000 milligrams, I'll put that at the beginning. The other way is to start at the end. That is to say, what do I want? I want doses per day. So let me find doses and day and set them up exactly where I want them to be. Like here's doses. So that's got to be on top, and here's days. So that's got to be on the bottom, and then everything else that comes along with that, I just got to figure out how to cancel that out. So I might start with 1 dose per 5 milliliters of solution, because I know I want doses on top when I'm done with the calculation at the end. And now to get rid of 5 milliliters, I say, where else do I have milliliters of solution? Oh, I've got it right here, so I'll use that. 5 milliliters in 120 milligrams of acetaminophen. And then milliliters cancel, and I need to get rid of my milligrams of acetaminophen, and there's where I have acetaminophen. So I'm going to put that on top, so milligrams of acetaminophen will cancel, and put 1 day on the bottom, and milligrams cancel, and I get doses per day. You see the setup is exactly the same. It's just that what was at the end here is now at the beginning. So that's why I say start at the end instead of start at the beginning. But when I plug all of this into my calculator, of course, I'm going to get the same answer. Start out with 1 dose divided by 5 milliliters. Multiply that by 5, divide by 120. Multiply that by 1,000, and I get the same answer, 8.33 doses in a day. So hopefully you see there's not a right way to do this insofar as, do I start with 1,000 milligrams a day or do I start with a dose in 5 milliliters? You can start anywhere you want. And the beauty of dimensional analysis is that if you start in the wrong place, it'll tell you. You'll figure that out really quickly. So like as for example, I'm going to do this problem wrong just so you can see what I mean by that. Let's suppose you kind of don't know where to start. You feel frozen. You figure, okay, I just got to start somewhere. So I'm going to start with this guy here, 120 milligrams and 5 milliliters. And I say, okay, I know that I have 120 milligrams of acetaminophen in 5 milliliters of solution. And I'm going to cancel those out. So here's where I have milliliters of solution. That's 5 milliliters in 1 dose. So I'm going to put 5 milliliters of solution in 1 dose. And that cancels that out. And then I need to get rid of milligrams of acetaminophen. And I see that here. So I'll put it here. 1 day. Sweet. So I canceled all that out. I used everything they gave me. And now when I calculate this, the math is going to tell me 120 divided by 5 times 5 divided by 1,000 is going to tell me 0.12 is what the math says for the numbers. And then what the math says for the units is days divided by dose. And here's where the dimensional analysis tells you, hey, by the way, you needed doses on top and days on the bottom. And you have days on top and doses on the bottom. So this needs to be flipped in order for you to have the right answer. This is what I mean by dimensional analysis tells you when you're doing it wrong, because you'll get the units in the wrong places. It'll be very clear if you're paying attention to the units, which is the point of dimensional analysis. So there is that. And if you do end up in that spot, you can go back and you can flip everything along the way, or you can just flip this. And it's this 1 over x button that flips it. Might be an x raised to the -1 button. Flip it. Look, there I've got it. 8.33 doses per day. All right, let's do another one because these are a little bit challenging. I'm sure you'd probably like another example here. So we're going to look at example number 2 from the lecture notes. This says a doctor prescribes an intramuscular injection of 0.35 grams of Roboxin. The injectable solution is given at a concentration of 100 milligrams per milliliter. And we want to know how many milliliters should be administered. Just going to set this up here. So first thing we're going to do is pull out the information that's given. So we're saying that the prescription is for 0.35 grams of Roboxin. I'm just going to put a capital R. The solution is given at a concentration of 100 milligrams of, that's Roboxin, per every 1 milliliter of solution. And I could also alternatively write that as 100 milligrams of Roboxin is equal to 1 milliliter of solution. Take that conversion factor back to its equivalency. And they want to know, this is step 2, what are the units? They want to know how many milliliters. Okay, so we know that grams need to be given. We're given a solution with milliliters, that's great. But that solution has milligrams of Roboxin and not grams of Roboxin. So what was not said here, but what you will need is some sort of conversion factor between grams and milligrams. Well, that is easy. You guys know how to do that. You've been practicing metric conversion factors for at least a couple of days now. So you can come up here and say, all right, we need to add another conversion factor. I know that 1 gram is equal to 1 gram. And milli means times 10 to the negative third. Therefore, 1 milligram equals 1 times 10 to the negative third grams. And that's for anything, including, as is this case, Roboxen. We'll put that in there. And that should get us there. Okay, so I'm going to go backwards because I like it better. You need to do whatever way works for you, so long as it gets you the right answer. Whatever you feel the most comfortable with is what I recommend. There's more than one way to do this. But I'm going to go backwards because I really like that. So we say, well, I want milliliters. There's the milliliters. I'm going to put that front and center, 1 milliliter of solution, because that's the unit that I want at the end of the day. And that comes with 100 milligrams of Roboxen. Now, I need milligrams. I've got grams, grams. Here's milligrams. Okay, so I see that 1 milligram of Roboxen is 1 times 10 to the negative third grams of Roboxen. And I'm going to put the milligrams on top because I want them to cancel. And then, now that I've got grams on the bottom, now I can use this grams on top, 0.35 grams of Roboxen, so that the grams will cancel. And now I know I'm done because I have only the units left that were the ones that they asked for, is the milliliters of solution. So I'm going to plug this in. I've got 1 milliliter of solution divided by 100 milligrams of Roboxen, multiplied by 1 milligram of Roboxen divided by 1 times 10 to the 3 negative. 1 times 10 to the negative third. There we are. Multiply that by 0.35 grams of Roboxen, and I should get 3.5 milliliters of solution that needs to be administered. It's pretty slick. Now remember, we can go backwards. The rules for algebra say that it doesn't matter what order you do multiplication and division in, right? A times B times C is the same as A times C times B, and so on and so forth. So long as you remember that everything on the bottom stays on the bottom, has to be divided, and everything on the top has to be multiplied, then that will get you there. Let's do one more prescription problem here. This one comes again from your lecture notes. Number 3, doctor prescribes Dramamine at a dosage of 1.25 milligrams per kilogram for a child who weighs 43 pounds. And if Dramamine comes in 50 milligrams of tablets, how many tablets should be taken? All right, so we see that Dramamine comes in this prescription, and this is milligrams of the drug Dramamine per kilogram of the kid or the child. All right, so we see, we can pull out the numbers. 1.25 milligrams Dramamine equals every 1 kilogram of child. We're given that the child weighs 43 pounds. Now we can see, ooh, kilograms, pounds. I'm going to need a conversion factor. And I would have to give you something, right? Because we don't need to know English conversion factor. So I'll give you this. 2.205 pounds is equal to 1 kilogram. And we also see that it comes in 50 milligram tablets. So 1 tablet of Dramamine equals 50 milligrams of Dramamine. And then here's the big question. What are they looking for? They want to know how many tablets. So if we can get our units in tablets, then we should have the right answer. So I'm going to work backwards. Again, I'm going to say I start with tablets because that's what I want. So it just makes sure that it's on top when I'm done. It's really easy to work from there. So there's 1 tablet of Dramamine in every 50 milligrams of Dramamine. Now I need to get rid of milligrams of Dramamine. I can check this off. I've used it. Here's milligrams of Dramamine. I see we have 1.25 milligrams of Dramamine in every 1 kilogram child. Milligrams of Dramamine cancel. Use that. And here's kilograms. And of course, this is a conversion factor that works for anything, including a child. But if I do it for a child, then every 1 kilogram of that child converts to 2.205 pounds a child. Cancel those. And now we have a 43-pound child. So when I multiply all this through, everything cancels except for the number of tablets of Dramamine, which is exactly what they're asking for. I can say 1 divided by 50, multiplied by 1.25. I can skip the ones really. So divided by 1 times 1, divided by 2.205, multiplied by 43 pounds. And that should give me 0.48 tablet. Now, you know and I know that nobody's going to cut a tablet that carefully. So it's appropriate to say, okay, that's about equal to half tab. That's how much this child is going to be taking. All right, I hope that this was helpful. This is something that takes lots of practice. You might be able to look up dosing conversion problems on your internet, see what you can find. You can be certain that there will be several problems like this on the exam. So this is something you should really practice. The worksheet has lots of practice problems too. So I hope this was helpful, and I hope you guys have a lovely day.